the International Standard Organization, ISO, generated what it called the OSI Reference Model, which has greatly influenced the thinking about protocol stacks. The protocol is a reference model that formally defines what it means by a layer, a service, and all other jargon we're using. It defined a full service architecture describing the services provided by each layer and each service within a layer. It defines a set of protocols that can implement the services, but of course allows other protocols to be included as long as they obey the interfaces. This slide is taken from the OSI standard, and it shows that it divided the network basically to 7 layers, from the lowest one, the physical layer, to the application layer at the top. At the two ends of the connection, these are the end hosts, and they have all the 7 layers. In between, inside the network, only the lowest 3 layers exist, since we try to do anything we can end-to-end without the network involvement. Communication, of course, is all about data. When an application has a data, it adds to it some header, application header, that describes what this data is and pass it down to the presentation layer. This layer adds its own header, pass it down until it reaches the transport layer. Each layer is adding a header, and this entire header plus data of the previous layer is regarded as the data for the layer below. At the network layer, in many cases, the transport layer, the transport packet, PDU, what we call, is too large to be transmitted. So it is divided into smaller chunks. Each is equipped with its own network header and transmitted through the network. The data link usually adds to the data both a header and a trailer because it needs to delineate the data frames from each other. And then eventually the physical layer transmits bits.